Hey everyone, and welcome back to our channel. Today, we're diving deep into a topic that is absolutely fundamental for anyone in the quality and manufacturing world: Statistical Process Control, or SPC. If you've ever wondered how top-tier companies consistently produce high-quality products, a big part of the answer lies right here. SPC isn't just about crunching numbers. It's about understanding the voice of your process, enabling you to make smart, data-driven decisions that save time, reduce waste, and boost customer satisfaction. So, what exactly is SPC at its core? It's a method of quality control that uses statistical methods to monitor and control a process. Think of it as a health monitor for your production line. It helps you see if your process is stable and behaving as expected, or if there are issues creeping in that need your attention. The goal is to move from a reactive inspect and reject mindset to a proactive predict and prevent approach. This is crucial for meeting the stringent requirements of standards like ISO 9001 and IATF 16949, which are all about robust process control. The foundation of SPC was laid back in the 1920s by Walter A. Shewhart at Bell Labs. He introduced the concept of control charts, which are still the most powerful tool in the SPC toolkit. Shewhart identified two types of process variation: common cause and special cause. Common cause variation is the natural, inherent randomness in any process, the background noise. It's predictable within certain limits. Special cause variation, on the other hand, is caused by specific, identifiable events like a machine malfunction, a new batch of raw material, or an operator error. These are the signals that something has changed and needs to be investigated. The main job of a control chart is to help you distinguish between these two types of variation. A process is considered in control when only common cause variation is present. This doesn't mean it's perfect, but it is stable and predictable. When a special cause occurs, it shows up on the control chart as a point outside the control limits or as a non-random pattern. This is your cue to act. By identifying and eliminating special causes, you bring your process back into a state of statistical control. Once it's stable, you can then work on reducing the common cause variation to improve the process capability. And that brings us to CP and CPK. Let's start with CP, the Process Capability Index. CP measures the potential capability of your process. It compares the width of your customer's specification limits to the natural variation of your process, which we typically measure as 6 times the standard deviation. A CP value of 1 means your process variation just fits within the specification range. A value greater than 1 is great. It means you have some wiggle room. A value less than 1 is a red flag, indicating your process variation is wider than what the customer allows. But CP has a limitation. It assumes your process is perfectly centered. What if it's not? That's where CPK comes in. CPK, or the Process Capability Index adjusted for centering, is a more realistic measure. It looks at the distance from your process average to the nearest specification limit. Because it considers the worst-case scenario, CPK can never be greater than CP. A high CPK, typically 1.33 or higher, is the gold standard, signifying a process that is both capable and well-centered. Let's talk about the tools. The most famous are the Shewhart control charts. There are different types of charts for different types of data. If you're measuring continuous data like dimensions, weight, or temperature, you'll likely use X-bar and R charts or X-bar and S charts. The X-bar chart tracks the average of subgroups, telling you about shifts in the process center. The R chart or S chart tracks the range or standard deviation within those subgroups, telling you about changes in process variability. If you're dealing with attribute data, things you count, like the number of defects or non-conforming units, you lines use charts like the P chart for the proportion of defectives, or the C chart for the count of defects per unit. Choosing the right chart is the first critical step to successful implementation. So how do you actually implement SPC? It starts with a plan. First, identify the critical processes and key characteristics you need to monitor. You can't and shouldn't monitor everything. Focus on what truly matters to your product's quality and your customers' satisfaction. Next, collect data in a systematic way. This is crucial. Make sure your measurement system is reliable, a concept known as measurement system analysis, or MSA. Bad data will lead to bad conclusions, no matter how sophisticated your charts are. Once you have good data, you can calculate the center line and control limits for your charts. These limits are calculated directly from your process data. They are not your specification limits. This is a very common point of confusion. Your control limits represent the voice of the process, while your spec limits represent the voice of the customer. A process can be in control but still produce parts that are out of spec. That's a capability problem. With your chart set up, you begin to plot your data in real time. This is where the magic happens. You and your team on the shop floor can see how the process is behaving instantly. If a point goes outside the control limits, it triggers an investigation. This is where a well-defined reaction plan is essential. Who is responsible for investigating? What steps do they take? The goal is to find the root cause of the special cause and implement a corrective action to prevent it from happening again. This continuous feedback loop is what drives improvement. The benefits of doing this right are massive. First, you get a dramatic reduction in waste, rework, and scrap because you're catching problems before they result in large batches of bad product. This directly translates to cost savings. Second, you improve product consistency, which leads to higher customer loyalty and a stronger brand reputation. Companies that are serious about quality, from automotive to aerospace to medical devices regulated by the FDA, rely heavily on SPC to ensure their processes are stable and capable. It's not just a quality tool, it's a business excellence tool. Finally, SPC empowers your team. It gives operators on the front lines the tools to understand and control their own processes. This fosters a sense of ownership and engagement, shifting the culture from firefighting to proactive problem solving. When people have the data to make informed decisions, they feel more valued and motivated. In summary, statistical process control is a powerful methodology for understanding, monitoring, and improving your processes. It helps you differentiate between natural variation and real problems, enabling you to take targeted action. By using tools like control charts, you can achieve a stable, predictable process that consistently delivers quality products. It's a journey, but one that pays huge dividends in efficiency, cost, and customer satisfaction. Thanks so much for watching. If you found this video helpful, please hit the like button and subscribe for more content on quality management and continuous improvement. Let me know in the comments if you have any questions or what topics you'd like to see next. See you in the next video.